Hey everyone, today we're going to look at factoring polynomials by grouping. It's kind of an extension of GCF. So let's get started. So make sure you understand that when we factor, even if there's no numbers or anything like that, we can factor common variables, and we can always factor the lowest degree. So for instance, there's no common A, there's no common B, there is a common X to the first degree, and we could factor that out, and it would look like this. Okay? So remember what you did when we were factoring with the GCF, and we're just kind of doing that again. And but this time we're going to look and see if we have what happens when we have two common binomials as factors. So what ends up happening is you can end up rewriting this like this right here. Okay? And this, going to this, makes sense because we know that this right here is going to be distributed to the x and the 5, which is why we can do split it up like that. And we know we can split this up like this because we know the b is going to be distributed to the x and the 5. So we're just going backwards. So when we see one like this, you know that it's going to end up looking something like x plus 7, right? The x and the 7 term, and the common 3a plus 2. The x is going to multiply into both of those, and the 7 is going to multiply into both of those, so you end up with 4 terms here. So when a polynomial has 4 terms, we are going to factor it by what's called grouping, okay? So essentially what we're going to do is draw parentheses around two different terms, or four terms in that case, and make two groups. We're going to factor the GCF out of both of those groups, and then we're going to do what we just did, which is factor out a common binomial. So looking at this problem, there is a small error here. Make sure you have a plus right here. Okay? So when we do this, what's going to happen is we're going to make two groups. Okay? And keep that sign right there with that term. So if I rewrote that over here, I'm going to have b cubed plus 3b squared plus, still addition, I'm just writing my parentheses to make the group, b plus 12. Okay? And then we're just going to factor the GCF out of each one. So for instance, there's a b cubed and a 3b squared. There's a common b squared here. If I take a b squared out of b cubed, I'm just going to wind up with b to the first. Plus, I take the b squared completely out, they'll simplify. This will be plus 3. Here is a common factor of 4, GCF of 4. 4 goes into 4, 4 goes into 12, so I can take out 4. That's going to leave me b plus 3. And you can always go back and check these to see if it turns back into this. And then as the instructions say over here, just factor again one more time. You can see we now have a common binomial. We have b squared plus 4. And b plus 3. And that's all there is to it. So it's making two groups. It really turns into just two greatest common factor problems, just for binomials. Okay, so nothing crazy. And then just knowing when you have a common binomial, you can turn it back into this because you know they're going to be redistributed. They're being distributed here, which looks like this also. So look at this one. We have 4 terms. Let's try our grouping. Here it is. And then we can check for GCFs in here. So let's see what happens. There's 3 and 2, nothing there. X and X, we can definitely take on X. And there's no A, so we're going to take on X. So we'll be left with the X is going to go, X is going to go. We'll be left with 3A plus 2. And then 21 and 14, we can take out 7. And if I divided those by 7, I'd have 3a. Sorry.
The video just skipped there. You'll kind of notice that when you get this first part right here, it's supposed to match right here. So you'll wind up with x plus 7 and 3a plus 2, and that's it. That's all there is to it.
So on this one, you want to group up here. Check your common terms. 6 and 3, definitely a 3. X squared and x, take out the lowest degree. X, if you need to divide through, 3x, because this confuses some people. 6 divided by 3 is 2. X squared divided by x is just a single x. And then 3x divided by 3x minus also. You're just going to have a minus 1. Over here, we have a leading negative 4. We always want to take out that negative. But when we take out that negative, it's going to change this sign also. So the common term here, we got 4 and 2. The GCF is going to be 2. And we're actually going to take the negative out because we want to take, it works much nicer when we solve them when we take the negative out. So we can say negative 2, right? And this is why the signs change. So 4 divided, we already took the negative out, so that sign's going to become positive. Sure enough, we should wind up with 2x minus 1. We took the negative out here. Minus 2 divided by 2 is 1. So then finally, our answer is 3x minus 2 and 2x minus 1. Continuing on, let's just check out example 4. So again, 4 terms, that's the key here. Put them together. Common x here, so we can take out an x. And when you take out the same term, you know it's going to go away. So that's why sometimes I don't write here. So plus 2. 4 and 8, we can definitely take out a 4. So the 4 comes out. Y, 8 divided by 4 is going to be 2. And sure enough, matching binomials. X plus 4 and y plus 2. I'm going to leave example 5 up to you, and just call me over. Let me see if you get it right. Sometimes, however, the grouping might not match up. Like if I did my groups like this, there might not be any common terms, but if I rearranged it a little bit, then it would work. So for instance, I can put my BC and my BD together, and I can put my AC and my AD together. And I'm going to move around the positive terms so I don't have to worry about the signs. So the negative BD is going to stay with it. So watch what I do. I'm going to move my BC in front, say minus BD, and I'm going to move my positive AC over here. So plus AC minus AD. And now we have something we can factor. Group it. Common B, so we can then say C. If we take the B out, take the B term out, divide, it's going to simplify, so we'll just get C minus D. So over here, the binomial should be what? We know it should also be C minus D. In order to do that, we factor out that common A. You'll see something like that. So now you see common C terms, so you get B plus A and C minus D. Sorry, my D's look kind of tricky there. So for instance, you might want to try and look at one like this. You can definitely put the let's see, the CMs with the 5M and the CN with the 5N. So here's what's going to happen. This time I'm actually going to move the negative because I'm going to keep the positive here. So I'll have 5M, move this guy with this term, minus CM. So all I do is just move it over. I'm going to keep my 5N right here. I'm going to move my CN around over here. So all I did was switch places with these two. Okay. And as you can see, we got a common term here. There's a common M. So we get 5 minus C. We got a common N. So we also get 5 minus C. So then we get, finally, M plus N and 5 minus C. That's it. Okay. So if you can handle that, grouping's fine. These are a little harder than what you're going to mostly see. You're mostly going to see ones more like example 3. So if you feel pretty good about example 3, then you're going to be in great shape. So let me know if you have any questions, and